Okay, yeah. So welcome to Shipa Office Hours. Get your learn on, just to kind of talk about things. And so, my name is Ravi. I'm the field CTO here at Shipa. Worked at a few places, most recently at Harness, and I've worked at a few other spots doing distributed systems things. I'm not really good at software. I never got anything right the first time. If I did get something right the first time, it's wrong. And I say that trial and error makes software. And so with that in mind, software is a life of iteration. And so what are we going to be talking about today? Kind of the first thing is, okay, like why, the road to Kubernetes, I call it. As you're jumping on the Kubernetes train, how did we get here, and what is the stuff that we kind of left behind in our previous non-Kubernetes life, and then kind of showing just a better way to view apps in Kubernetes. And so let's talk about just the Kubernetes journey, right? And so kind of my background, this is from a development standpoint, right? Like, when I started as an engineer, I typically wrote Java, and we deployed to application servers back in the day, and that was it. My primary focus was the binary distribution, and yeah, someone else deployed and someone else managed the application infrastructure to where we are today, right? And so if you take a look at even the Java language is much more granular, and each one of these paths as you go left to right, it's more decisions, right? You have to automate the build, lay down infrastructure, you have to do a whole bunch of containerization stuff. It's not even fair to say, okay, we want to go use Docker, and then we're going to go to Kubernetes, and now we have to package things with Helm and lay our different environments down with customized overlays, and then we had to pick our observability stack, and then we have to pick what cloud provider we're going. And each one of these are bespoke decisions that you're going towards. And so that kind of leads us, like, there's multiple panes of glass, there's multiple systems. And from a developer standpoint, like with all this expertise shifting left, left towards the development team, like who really owns everything, right? And so it's this concept called Conway's law, is that your system design will mimic organizational communication. And so depending on which one of these nifty folks owns the path, you're going to get a little bit different experience. And it kind of like with Kubernetes is very interesting, because in my Kubernetes journey, when I started using Kubernetes in 2015ish, it was clearly on app dev. Like our cloud engineers and DevOps engineers, or pardon me, and system engineers would not even touch it. They're like, it's just like you running JBoss, young man. Go in Kubernetes. And then as workloads became more important, it's then the system engineers and those principles came on. So the whole platform engineering, the purveyor of the platform model came on, but it's direct developer interaction wasn't there. And this kind of like goes back to like the olden days, right? Like, so with the olden days, we statically provision things and someone else provisions our infrastructure. That wasn't the early Kubernetes days. If you were running workloads in 2015, 2016, most likely all the business controls that this model set up was not there, right? And so this is why there's a little bit of a gap, right? Because now today, the direct control of the clusters, or minus if it's a development cluster, are your developers having access to prod? Probably not, right? Because it's common sense not to do that. And that's the changing of the role, right? The platform engineer now kind of orchestrates, maintains, scales, administers your Kubernetes clusters, basically making sure that you get onboard and offboard. But that person is not immune from the myriad of tools that they have to do too. So to provide that functionality to me, it's I always like to say I'm not a kernel engineer. I don't know, actually I do know, but I like to say I don't know what eBPF is. It's not, something that I'll be writing. Is that there's just lots and lots of tools out there, right? Lots of platforms, lots of just to get functionality to your end users. And what does that mean? And kind of like, this is it, right? Like, let's just role play. And so let's say Bruno was my development manager. It's my first day on the job, and it's he tells me, hey, we need to make a change to something that's running in Kubernetes, and I'm a software engineer. And I might roll my eyes and say, okay, I don't care where it runs. I need to focus on the feature, but at some point, it's that push and pull. Like, is Kubernetes a development tool? Is it an operations tool? Well, where does it fit? You might say, we have it running in dev, and so I was like, okay, then we have a development namespace, development cluster. My development namespace is called not default, so I don't put everything in default. And this is what I can do. I just do a qtcl describe the pod that's running on and what the object is, and this is it. This is literally what I see. And Bruno has tasked me to make a change to the application. It's like, okay, I see some labels. I see a container. What do I go touch? Give me the source code, right? And so, but this is the purview, and this is the application. This is what is available to your teams today out of the box. And if you're a developer like me, this doesn't mean much. It doesn't make much sense. I mean, to me now, like legitimately, I understand what this means because I've been using it for a while, but it's for most, it can be a little bit difficult. And this is where Shipa really kind of steps in, right? And so let's take a look at the mighty Shipa. I had the right tab. There we go. Like, I think I had these these URLs written. And so let's I'll just walk quickly show how the example is up. So I deployed an application through Argo, right? So I deployed an application through Shipa on Argo, and so that's some of the art of the possible that we have here. And let's actually take a look at what a deploy to mean. I can give it its office hours. I'm not going to kind of go through how let's say everyone's curious how we actually set it up. I'll go to the end of the huzzah state. And so I have a few applications that are running. I had one that was deployed. Shipa also has the ability to ingest application data, right? So you don't have to deploy through Shipa for Shipa to pick up on things. This is this particular column here that says Shipa manage. You'll see yes, no, yes, no. The applications I had deployed through Shipa have a yes and a yes. I deployed one also with Terraform. But also I ran a Helm chart, as Bruno was saying. I just ran something non-sexy WordPress, a Helm chart to install it. Shipa was able to pick it up. So let's actually take a look at what this application map is. So just going back to, let me pull up that last slide. So we can remember what it looks like. So actually, no, I'll do it from the command line. Let's see. If I was tasked with looking at something, right? So I could be kubectl, describe pod. Actually, I need to get the pod first. So, and we have to, kind of figure out hey, tell me a little bit more about what's, what's running here, right? You might be okay, let me go about and literally do that one command to get kubectl default and then the pod name. And I'm provided with this, right? For what's going on here. There's just a lot of stuff to kind of go through. And so with Shipa, we kind of come back and take a look at an application. We have all the application centric information here. I mean, there's lots of actions we can do. We could redeploy a new version of it, a new image and whatnot. But let's actually take a look at this application map. So instead of this, what does this mean here? We're greeted with this, right? And so it's a much more application centric view. We can kind of say, these are the configuration files or the dependencies that made up the application. So it kind of helps me pinpoint I need to go make a change in app.yaml, right? Also, it kind of tells us other things. Hey, we have a configuration map. Some of the values will be coming from a config map. This is actually part of a deployment object. And so it really starts breaking down the life cycle and also what prudent areas to make changes, right? Hey, these are the load balancer or the ingress rules. Here's the, whoopsie, magic mouse. Here are the load balancers or services that represent the application. And also hey, this what's the account that made it to search made the change. And with that, you're presented a much more easier dashboard of visualizing your applications. Now this one was deployed through Shipa. You might say, well, depending on what what do I want to call them, students, like our peers here on the call, depending on if you're on a team like a DevOps team or a platform engineering team, or if you're a developer yourself, you can quite easily just point Shipa to ingest the applications, right? So here's one that was imported, and you get very similar details. And I can actually tell you how they were imported. Similarly, we also capture networking information, and so if we kind of take a look at back at the map here, one of the things that really confuses me is like the networking objects, right? But here, we're showing that this object is not very secure, but it's it's taking in ingress traffic from the public internet, and it's speaking back, egress traffic back to the public internet. If there was more rules, let's say I wanted to add like, hey, this application go and talk to another service or application, that would show up here. And Shipa can actually, underneath the covers, is wiring those CRDs in your service meshes for you. So if you're using Istio or Trafic or Nginx, Shipa will wire that to you. I'll just pause there if there's any questions. So let me see if anybody raised your hand.
Can I be risky and show that process and see if it works from my side?
Sure.
I mean, I don't think I can share my screen. Yeah, now you need to make me host again.
Oh yeah, let's go. Yeah, let's see. Let me click make host. Okay.
Oh, nice. Okay. So complementing what Ravi showed, right? From an end state perspective, how do you get there? So I think the first thing Ravi had is an account on apps.shipa.cloud, right? So you can create an account and it's free. It doesn't involve any cost. You can get started free. And in my case, what I have here, I have a cluster, a GK, but that's kind of doesn't really matter where it's hosted. It can be anywhere. And I have just deployed an application, the WordPress using Helm, right? Just a simple app, but it can be any app. What I have on the Shipa side, once you do this, or let's say you join in, you come in, you create your account, the first step for you is to create a framework. And that's kind of how your application or Shipa is going to connect to your cluster, to your underlying cluster. And you have an option here that is discover existing applications. So this is going to prompt you only for the options that you need to enter, and so minimizes the amount of stuff you need to go through. Here you can enter the framework name. It could be WordPress, it could be whatever name you want, for example. And the namespace is going to be the namespace where your application is deployed. So in my case, it will be, for example, default, right? Because that's where my WordPress app is deployed. Plan is a resource plan, kind of resource consumption limits that later it can be used for different things as you kind of consume this framework later. And the team, the Shipa team. So those are kind of the minimal things that you have to enter to create this framework to be able to discover your apps. But here comes the part that is important, right? It's entering a label, and that's how Shipa is going to match. And that goes back to Ravi's point. This is how Shipa is going to discover the apps in your cluster. If I go here and I do, is this too small, or can you see it, Ravi?
I can see it. I can see it fine, but I have like a 34-inch monitor, so I might be cheating.
If it's too small, folks, let us know. But if I do get pods, for example, and I do describe pod, and I check the WordPress pod, I can see that it has, for example, this label, right? And this label is common actually with the other pods. So let's see, Helm used the same label across all the pods related to that application. I already have a framework created here. I'll just use that one. So I can enter this label here, name. I'll just enter this label here. And that's it, because then Shipa will start reading that namespace for that label, right? Let me just make sure it's pointing there. Yeah. And the naming suffix, you don't need to enter anything. It's just if you want Shipa to say, as it discovers MySQL, you don't want to show as MySQL. You want to show like dev-MySQL or whatever. But here's what you would need to enter. And then in a few seconds, Shipa will start then mapping kind of all those labels and start kind of showing up the applications directly in here in your pod. You can see that this is coming now. It's coming up as an error in the app. So there is a problem with the app. Great. You can see what's happening. But that's the process. Shipa will kind of read the labels. And as long as the framework you created is connected to or is pointed to that namespace, and just as a step, you create the framework, you go to cluster, and you can connect that framework to your cluster. What you're going to need is just kind of the name, a framework in here. And does that make sense so far, Ravi? Let me just kind of
yeah, it makes perfect sense to me. I mean, it's really easy to get when I first started, I didn't quite understand what the purpose of this was, the ingestion, but it's really helpful, like especially for if you're learning about Kubernetes, and you can kind of see like how different people assemble different applications. Like I was curious how Bitnami, that's the helm chart I use, like how they actually put it together, and the visualization like certainly helped.
Yeah, and on the process, like when you create the framework, the second step for you is to connect it to a cluster, and you can come in here and enter the name of the cluster and the framework, and then it's gonna ask, Shipa is gonna ask you for the details of that cluster to connect to it. Let me see if we can find the documentation link for that. But aside from the documentation, here's a quick cheat I use, which is a shell script. You run, and as long as you're connected to kubectl, it creates an account for a service account for Shipa, and it displays you the control plane, the token, and the certificate. So it's a little kind of cheat code I use. And then it shows the apps, assuming the app was fine. But at least you can see the problem here, and you can see, hey, here's a problem with my container, right? You can quickly pinpoint where the problem is. And it starts populating this massive network map, right? Because now there's no network policy and everything can access. So if you're a DevOps person, you can quickly identify that a lot of the your network communications is basically open for your apps.
Yeah, definitely they can, just taking it a couple clicks down, like, they can assign network policies and stuff to it. Like, like if you see that, there's some work to be done, but other than that, like it did show you everything that's going on.
I have a network policy here. I'll try to kind of apply and see if it works. It says it created. I don't know if it's updated. I don't think it is, but oh, there you go. So I just applied a network policy on the background for that application, and I can see if I see my application here, for example, or my network policy. It's saying that only policies with this, only pods, sorry, with this label can communicate among themselves. So now the dashboard map shows, okay, my WordPress app can only receive ingress from my MariaDB that is sitting on this framework, right, or connected to this framework. So as your team kind of adjusts the network policies on the background, then you can now see everything that is happening kind of in real time as well. I'm not sure if that's helpful.
Yeah, I mean, I suck at networking, right? So like if you go back to like the network policy YAML, like it was really hard for me to visualize what that actually meant. Like, yeah, it's like, okay, it's just like 18 lines of YAML, what does that really mean? And like this is a Kubernetes object. This is not a Shipa object that Bruno was applying, right? And like just like that, like you were able to see like, oh, this is what this change meant. Even if you're learning, like I haven't written a networking object until I came here, and it was like yeah, now I know how the change impacts, right? And that visualization is real, like near real time, so it's pretty cool.
Yeah, but and I fully agree, and at least this is you in a matter of seconds, or not seconds, come on, a couple minutes. I'll give it a couple minutes. You can just go and create a framework, map the namespace you want, kind of the label, connect it to a cluster, and your developers, they get kind of this view right here, right? And then from here, if your developer wants to keep on using Shipa and deploying their applications and kind of get all the other benefits, you can. But this is a quick and painless way to deliver value, right? And you can give this to your developers, and they can have now visibility over who owns the application as transactions, because now the pod is not working, but as transactions come in through, you can see kind of resource consumption, application performance. You can see information about the unit, which there is an error. See, it helps you find applications that are in problem. But at least now you can get that really quick and up and running in a couple of minutes. Yeah, I think. What do you think, Ravi?
This is good. I would try it out. Well, I'm biased because I work here, but yeah, I'll try it.
Nice. I think we covered, right? Any questions? If anyone has questions or thoughts, feel free to post or ask.